Okay, so we're going to talk about Sanoid tonight. Sanoid is my own project. I would say pet project, but I think it's a little bigger than a pet these days, hopefully. I am a small business owner down in Columbia, South Carolina. Actually, two small businesses now. One being JRS Systems, which you saw on the slide before. That's actually my day-to-day consulting business. The new venture is Openoid, which you see the logo there. And Openoid's purpose in life is a little bit more narrowly focused than JRS Systems. JRS Systems is, your usual IT consulting firm. Whatever it is you can't figure out how to do, we'll either do it for you or show you how. But the focus on Openoid is specifically on the Sanoid product, which is what we're going to talk about tonight. Before we really get into the nitty-gritty about the product, I want to talk about a little bit of history. This is my friend Tim Anderson. He's currently director of IT for a pretty large insurance firm in Seattle. I'm sorry, not Seattle, Portland. And all the way back in 2002, he said something to me that I thought was just absolutely ridiculous. We were having a conversation online, and he tells me the IT hero is dead. That guy that everybody's like, oh no, the server's down, everything's lost. We hope that this guy can do the magic and, perform these arcane rituals and get the data back, and, hours and hours of sweat and hope and prayers later, yay, the system's back up and everybody's, bowing down to it. So that's exactly what he's saying. This guy is dead. This doesn't happen anymore. Tim said, and again, all the way back in 2002, Tim tells me, well, now we have policies, and we follow our policies. And when we follow our policies and our procedures the way that we've laid them out intelligently, we know that everything is backed up. We know that we have a reaction in the book ahead of time for any situation that can arise. And because we do that, we don't need this guy with the cape. I told him that was stupid, because I work in small business, and this is what getting a new client usually looks like. Something is just completely destroyed off camera, stage left, somebody else got fired, and your phone rings. And now you have to come in and rescue this horrible thing and, start over from scratch. To be honest, the big difference between, you that's picking up the phone and the last guy is you managed to fix the thing that they destroyed. And when it happens again, hopefully, you can fix that too. There were just still, in the world of small business, there were a lot of problems that just couldn't be solved by these policies and procedures. So, after the explosion and you put all the pieces back together, the first thing that the business owner and the decision makers want to know is, well, what does the Fortune 500 do? Like, I know this kind of crap doesn't go on at IBM. I know this doesn't happen at Microsoft or HP. What are these guys doing? I want to do that so I don't look like a jackass over here, with my stuff blown up and being down half a day. And so, the answer is you can't afford it. You can't do what they do. Keep in mind, this is 2002. This is before widespread virtualization. Back then, the enterprise playbook basically meant you don't buy a server to do a job. You buy about 3 of them, and one of them goes into production, and one of them is online in a test network, that you got a lab that you can do stuff in development, or you can restore backups to, or whatever. It's completely segregated from production. And another one of them is sitting in a closet doing absolutely nothing. It may be assembled, or it may just be a bunch of parts, but you can build the whole freaking thing out of parts in the closet. And you need that, because 4 years later, when the server dies, you don't want to be in a case of saying, oh crap, I better see if this obsolete motherboard that I have to get Windows to boot, because it won't boot without the system state, and the system state needs physically identical hardware. Well, let me go on eBay and find out if anybody's selling one of those used, and hopefully it'll work. In the small business world, this happens. In big business, no, but the answer to no is because, they have an entire fleet of these things, not just one, and they're maintaining it. The small business world, you can't tell a guy, okay, you need this one server, but I want you to buy 3 of them. It's not going to fly. Okay, so the thing is, we want these enterprise features. We want the stuff that the big boys do, and the big girls. But the problem is we don't actually want all the things that they have. We only want some of those features. We want the predictability. We don't want to have these nasty surprises. If you've got your MBA, then the term you're looking for is business continuity. You don't want an interruption in your ability to actually do business at the time when you least expected it, which is probably the time when you would be pulling in the most revenue if you could work what you can. We want minimal downtime. Downtime versus unpredicted downtime are really 2 different scenarios, though. In the small business world, it's more about maximizing those times that you can be really productive and you're really pulling things in. Scheduling some downtime here and there, honestly, it's okay. If you need the server to be down half a day, and most small business, and let's be honest, even mid-market, that can be arranged as long as we're arranging it, not just having it suddenly happen. And finally, rapid recovery. If something does just completely go kablooey, you want to have the plan in place, and you want to have that backed up fast, which for the MBAs in the crowd, we're back to business continuity again. We don't want downtime. And yet, for those of you who didn't either A, study business, or B, try to run a small business with people on payroll, the problem here is that if you've got 10 or 20 employees and your server is down for half a day, you are now paying 10 or 20 people to sit around with their thumb in for half a day and mess around on Facebook, and that's expensive. You don't want to have to do that. So how does enterprise do this? Well, these days, it's not 2002 anymore, and we've done away with the closet with all the crazy spare parts, and we've largely gotten away from Microsoft's insistence on welding Windows to system state and identical hardware. And we've done that by, and again, I keep talking about Windows. I know this is a lug. I love Linux. I love BSD. I love open source. I also love eating. So I end up having to support a lot of Windows, which means I talk about Windows a lot because I hate it and it's painful. And mitigating that pain is very important to me. But we will talk more about Linux, I promise. So anyway, in the Windows world, we largely got away about that by lying to Windows, which is the best part about virtualization. If you have to deal with the Microsoft ecosystem, is you tell Windows, hey, you're a special snowflake. You have this unique hardware that you can build your crazy little system state on that won't work anywhere else. And behind the back of your hand saying it's all virtual and it's bullshit. Because you can replace that with anything else, but Windows still sees the virtual hardware, so it still works. This is important because now you can get your business continuity much more easily. You don't need fleets of identical hardware. You just spin up a new VM, it presents the same virtual hardware, everything works, you go on about your day. But this stuff is pretty complicated. We get this diagram here, and we're looking. So we've got a close-up of a SAN array over here. I think that's not an Ecologic. I think that's an EMC. But so you got your storage array here. You've got a whole bunch of disks attached to that. Your storage area network, your transport network goes off to several servers, Windows, Linux, Unix. You've got maybe a tape library to back this thing up. It's complicated. You've got to manage all this stuff. And this network right here, not displayed, is anything connecting any of this equipment to actual human beings. This nice little cloud right here, it's just to connect your storage to your hypervisors. All of this has to be maintained in addition to the actual network that you have 10 users or 20 users or 2,000 users connected to. So it's a lot of burden, it's complicated to set up, and that's the missing feature in how enterprise does this, is all the money. To get a true enterprise virtualization stack, forget enterprise. To get a mid-market virtualization stack way down on the bottom end, you're looking at anywhere from 150 to 200 grand, and it's going to be a piece of crap. People would laugh at it. The performance is going to be terrible, but it's still going to be really complicated and error-prone and a pain in the butt setup. So we do things a little bit differently. We're going to look to provide the same feature set that enterprise virtualization stack provided. And one of the biggest things is, we'll talk about that in a second, about what the individual things are, but how we're doing it is different. Rather than throwing Scrooge McDuck piles of money at it, we're using open source technology, and we're using pretty much off-the-shelf commodity hardware. And the big players here, we've got KVM, Virt-manager for our virtualization. We've got ZFS for storage. We use VPN for secure connectivity, Nagios to monitor the whole thing. And we haven't had to pay anybody for a crazy license that we have to deal with sales holes and renewing it, and suddenly things disable themselves or whatever. Now, how we actually accomplish all this business continuity that I was talking about, this is the big thing right here, rolling hourly snapshots. And what this actually means is that every hour, on the hour, we take every single byte of data on our entire storage array, whether it be 10 gigabytes or 100 gigabytes or 20 terabytes. We take all of it at one atomic instant in time, and we snapshot it. It's immutable. It cannot be changed on disk. Now the cool thing about that is that doesn't mean that, say you had 20 terabytes of data on your 30 terabyte array, that doesn't mean that now you're just completely screwed because you can't even have another copy of your data. All it really does is lock those blocks down so that they can't be modified, and if you ask to modify those blocks, again with the lying, dishonesty is kind of our topic for tonight, what the file system actually says is, okay, sure, you can change that block, but really it just makes another copy of that block somewhere else with the changed data. So in your live file system, you're referring to some of the blocks from the snapshot, and you're referring to the stuff that you've changed since then over here. But at any given time, just as quickly, and I did say instantaneous taking these snapshots, right? Like, that's for real, instantaneous. You can roll back to them just as quickly. So again, I'll beat on Windows because I like to beat on Windows. Windows is terrible. Let's say that you come in on a Wednesday morning, Patch Tuesday hit the night before, and updates went on, and something went wrong in that process, and holy crap, the server is blue screened and it won't boot. If you've never encountered that, then you haven't done much Windows sysadmin. It does happen. So, you know, in the hardware world, if you're still just rolling on bare metal, this is terrible. You now have to make the choice of, I can either try to start fixing this thing in place, I can boot from alternate media, I can see if I can do some kind of repair install, or maybe try to manually hack the registry. You know, all that IT superhero crap. You got to bolt on your cape and go for it. But you don't know if it's going to work or not. And this is a crucial decision, because every hour that you spend trying to fix what's in place is an hour that you haven't even started restoring from backup. And restoring from backup is probably going to burn, I mean, best case scenario, you're down for half a day restoring from a traditional backup. So these are crucial decisions you're trying to make a huge impact on the wallet of, you know, whoever it is that's actually running that business, be it yours or, you know, be you a consultant who's working for somebody else. So with these rolling hourly snapshots, if you've got a VM running on Windows and your storage takes rolling snapshots like those enterprise virtualization stacks do, or like we're going to do with this platform, you don't do any of all that. The server blue screens and it won't boot. Who cares? Go back to the most recent hourly, do an instantaneous rollback, boot it, go on with your life. You can apply those updates again later, but in the meantime, your business continuity has not been interrupted. You're rocking, you're rolling, you're good to go. And what we're actually looking at on this screen, obviously we're not looking at some kind of a graphic of a snapshot. We're actually looking at Sanoid's configuration file, which is very, very human readable. So we've got a storage pool, which is creatively named pool, and we've got a data set. Now, a data set is a container that holds one or more files. In our case, we use it to hold the VM storage files, which is a single great big flat file. If you've got 8 terabytes of storage on a virtual machine, you've got one 8 terabyte big .qcow2 file that's the virtual drive for it. So we've got pool, data set, and we're going to use the production template. That's it. We're done. It's going to take snapshots. It's going to thin the snapshots when they expire. Everything's taken care of. If you look a little further, you can define your templates, and we defined the production template here. We're going to take 36 hourly snapshots, 30 dailies, 3 monthlies, and 1 yearly. That's all you have to do to make all that happen. So every hour it's going to take an hourly, every day at midnight, actually 1 minute before midnight, it's going to take a daily. It's going to take a monthly on the first of the month, it's going to take a yearly on the first of the year, and as you exceed your maximums on that, it will thin the old ones. It'll get rid of the old ones, so everything just rolls neatly without you having to worry about it. So another big feature is monitoring. I had Nagios on that slide a little bit back before. This is really important. If you want to have a true enterprise experience, you need to be monitoring both your hosts and your virtual machines. I use Nagios for that. We're not going to do a lot of talking about Nagios, individual features, but the cool thing about that is, I mentioned, so you have the server that won't boot on a Wednesday morning after Patch Tuesday rolls in, right? You don't want to find out about that when you're trying to, get done with your breakfast at home and your phone starts blowing up because you got 10 different users calling and whining because they can't get work done. It's much, much nicer to have your phone go bzz, bzz, bzz in your pocket before the users get into work, so you know what's going on and you can respond to it intelligently. If you're a third-party consultant like I am, the monitoring is really, really nice because the perception of your clients from you calling them and saying, hey, I see there's a problem here. Here's what our plan is going to be to respond to that. And they go, what are you talking about? Everything's working fine. You say, check again. And they see it's broken. That's a much, much, much better perception than when, again, you're sitting there thinking you're having a great day and your users call you and say, the server's been down for 4 hours. Why isn't it up again yet? And it's like, because this is the first you called me? That sucks. You don't want that. Asynchronous incremental replication. So this is also really, really key. We talk about snapshots and we talk about being able to roll back, but going back for business continuity and also disaster recovery, this doesn't protect us against some very significant failure modes. If the motherboard catches on fire on your production server, you don't want to just have everything be completely down until you can replace that motherboard. Your machine's not going to care about what motherboard or CPU you use the way that it would if you were rolling on bare metal since you're virtualized, but it's still, you're talking about, having to go fetch a motherboard, unbolt a bunch of stuff, rebolt a bunch of stuff, yada, yada, yada. It's terrible. You don't want to have to go through all that. You want to thing up. One of the ways that you can accomplish that is by having a hot spare machine. Even if you don't have a hot spare, you want off-site disaster recovery, and this asynchronous incremental replication is like magic if you've never played with it before. Anybody here used rsync? What do you think about rsync?
It's nice.
Awesome.
rsync, it pains me to say this because I love rsync. The first record you will find of me on the internet in professional capacity is on the rsync mailing list. rsync is terrible. rsync is fabulous at what it does, but can anybody here tell me what's going to happen if you try to rsync a single 8 terabyte file? It's going to read every single block of those 8 terabytes on both ends before it does anything over the wire. Now this block level replication, like we're going to use with ZFS, is different. Remember we talked about snapshots. A snapshot just saves a list of all the blocks and makes them immutable until you destroy the snapshot, right? So you've got 2 snapshots, point in time, and you already have the older snapshot on both machines. You already know what data you've got to fling over there. It's the blocks that have changed since you took that snapshot. Which already knows what those are because you have a second snapshot. So it just instantly starts spitting blocks over the wire. For on-site stuff, I usually do hourly replication to a hot spare box, which might be in the same rack on another side of the building, and it will usually take about 3, maybe 4 seconds to complete, even on multiple terabytes of storage. For off-site disaster recovery, I'll usually do it once a day, like in the middle of the night, and even over like a crappy little 5 megabit DSL pipe. I've got one customer with 2.5 terabytes of storage. They replicate to one of the owner's upstairs bins in about 17 minutes a night, typically. You can't do that with rsync. Strong hardware decoupling. We talked about this. You don't want your systems to be dependent on one specific particular part. Also, upgrades. In the small business world, this is another constant challenge I faced is, owners and decision makers that say, okay, it's time for a new server, this thing is slow, we want to give you money and we want you to make things faster. And you say, oh, okay, cool, all right, here's our plan, and here's going to be the new hardware, and okay, now we're going to have to set up all your applications on the new server and migrate all the data over, and I'm going to need all your install disks for all these niche applications you have, and keys and documentation, and I need to know a lot of information about your business so I can answer the things we set up. And the owner's like, whoa, 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 whoa. I just want this crap faster. I don't want to have to spend my time dealing with all this computery crap. I dealt with that scenario over and over and over again for 15 years, but once you get to virtualization, it gets to be really awesome because Linux itself, as we all know, doesn't really care a whole lot about the hardware. If you've got a Linux box, I'll just go ahead and pick on Debian or Ubuntu since that's what I use the most often. Let's say you want to replace every single bit of hardware in a Debian or Ubuntu or Mint box. The worst thing that you might have to do is rm etc udev rules.d 70-networking so that your new NIC will still go into F0 like the old one was. And that's it. You're done. Everything works. So this gets to be really awesome in the small business world when somebody says, oh, hey, my applications are crashing, I need more memory, everything's too slow, I want it to be faster. And you say, okay, and you bring in a new box and you shut down the old one, and you swap the drives over and you plug it up and you remove that one file and they're up and they didn't have to do anything really. So that's pretty sweet. All right, kernel virtual machine. Linux KVM, this is Virt-manager is what you're looking at on the screen there, and Virt-manager is a management tool to interface with the hypervisor that is built into Linux. One of the best things about KVM, there's a lot of great things about KVM, but one of the really nice things is that there's nothing to install. Seriously, it's built into the kernel. If you're running Linux, you already have KVM available. You may need to enable it in the BIOS on your motherboard, but you've got KVM. You actually don't install KVM at all. You just install Virt-manager if you want to actually use it to manipulate the machines. It's really simple, which I like. It's not super complicated. Anybody? Do we have any VMware folks in here? Full-on vCenter?
I've used it before, but not heavily.
So if you use full-on vCenter, I mean, one thing that you'll find missing here is you're not going to have those really lovely watercolor paintings of what is a host and what is a guest on like every page you go through. Virt-manager is very simple. It's very easy to figure out. This is the main Virt-manager window right here. You can see we've got, you probably can't read this here, but we've actually got connections to 2 machines that we're looking at here. Up the top is localhost, the local machine, and we've got 3 VMs running: Ubuntu, Trusty, Windows 10, and Windows 2012. Over here, we've got a connection over SSH to a remote box, and the remote box has copies of the same VMs on there. We can manage both the local VMs and the remote ones in the same Virt-manager on the same box, which might be the local machine, or it might be your laptop. You might be across the country. It all just connects over SSH and just works. It's fabulous. Double click one of them, boom, you got a console. We're looking at, again, my mortal enemy, Windows Server 2012. It's easy. There's your console. There's your stuff. Mouse around in it, do what you need to do. It's no different than working on hardware, except it sucks less. Storage is one of the other things about KVM, and I'll give you a demo of this a little bit later. I talk about being built into Linux, which is awesome. The other thing that's awesome about it is it blows the doors off of everything. If you're a Zen person, I'm sorry, I hate to tell you this, but your hypervisor is slow and weird and clunky. If you're a VMware person, well, VMware performs pretty well, but really, again, the best thing about VMware is those really, really gorgeous watercolors. They spend a lot on those. KVM is fast. It's faster than Hyper-V, it's faster than Zen, it's faster than VMware. About 4 or 5 years ago, I had a conversation with the Linode guys at a technical conference. And I asked them what hypervisor they were using for Linode, and they said they were using Zen. I was like, oh, I've used Zen. I really didn't like it. Really into KVM. They're like, oh, KVM. Eh. They kind of had this attitude like, oh, that bargain basement thing. Maybe that's cool for your little project, but for Linode, like, we need to rely on Zen. About 3 or 4 years later, and guess what Linode just did? They just swapped over from Zen to KVM on all their new stuff. If you set up a new Linode now, you'll be setting it up under a KVM, and you have a very prominent option to migrate any and all of them from Zen to KVM, which they would like you to do. One of the reasons they'd like you to do that is that in some cases, they ran a whole bunch of benchmarks on a whole bunch of VMs, evaluating this very carefully before they made their big infrastructure change, obviously. And they discovered a lot of the major benchmarks running anywhere from 5% to 300% faster under KVM than under Zen. Told you guys. All right, so storage, OpenZFS. I talked about these snapshots and the rolling back and the replication. All that is ZFS. ZFS is amazing. It gives you capabilities you would not dream of otherwise. What we're looking at here is we're just looking at Nautilus under Ubuntu. And we're actually looking at the snapshot directory for the production machine here, and the Ubuntu Trusty VM. So we see snapshots. Notice if you can't read it there, those are date stamps. 2014, October 19th, 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock, and on down the line. Each one of this might help you visualize the whole snapshot thing, because remember I told you that the VM, its storage is one flat QCOW2 file, right? Well, that QCOW2 file in its entirety shows up in each one of these folders. As you can see, Ubuntu Trusty.QCOW2.QCOW2.QCOW2. It's all the same thing, but it's at that exact point in time referenced in the name of the snapshot. And at any given time, you can clone one of these snapshots and spin up a new VM that's in the exact condition that it was at that particular point in time. You can instantly roll the whole thing back to that. Down here in our bookmarks, so we're currently on production on the local machine, there's an SSH-FS connection to the backup machine. And if this were real and not Memorex, and I clicked on that, you would see the exact same stuff on the remote machine, because it's block level replicated, which means that you throw this whole machine into the pit in Mordor, and it goes up in lava, and you can spin up those VMs immediately on your alternate hardware, wherever it is that you didn't throw it in the volcano.
So you don't have to pause the VMs at all to do this?
You don't. With a couple of caveats, you don't. If you don't pause your VM, what you're going to have is a crash consistent snapshot, as opposed to an application consistent snapshot. Now that should not matter unless you're doing incredibly, incredibly stupid and ancient and antiquated things with your VMs. If you're running a Windows VM, you're going to be running the NTFS file system, which is a journaling file system. The whole point of the journal is that when you start writing metadata onto your file system, it goes into the journal first, and once it's in the journal, the blocks get instantaneously, and here's this word again, atomically moved out of the journal and out to the main file system. The reason for that is if you're in the midst of a metadata operation that would otherwise corrupt the file system, and you yank the power cord out of the back, the machine will still boot when you turn it back on again, because it's just going to roll back that incomplete stuff in the journal rather than leaving your file system in an inconsistent and corrupt state. The same thing is going to be true of almost any modern application, especially with emphasis on the even vaguely modern. Moving back into the Linux world, we'll talk about databases. PostgreSQL and MySQL, both, unless you're doing something really old school, and if you are, you should stop that anyway, whether or not you're doing this, your databases are also going to be journaling. PostgreSQL is journaling. Microsoft SQL Server is journaling. NODB under MySQL is journaling. MyISOM is not. MyISOM, the old school storage engine, is not journaling, and it can come back inconsistent if you crash it. With that said, anything can crash at any time, and stop using non-journaling storage engines. If you're using MyISOM tables, quit it. Convert them to NODB, please. So, given that you're using journaling databases and you're using a journaling file system, there's really nothing wrong with a crash consistent state. Because remember, we took that snapshot atomically, so you're not going to have any corruption because some of the blocks are newer than some of the other blocks. Everything's instantaneous at that exact atomic instant, that cycle of the clock. Bam, you've got everything the way that it was. Which we're going to demonstrate. So to really demonstrate that we love something, we're going to destroy it. And normally at this point in the presentation, I would be showing you this video of me destroying a Windows VM. But the steering committee has told me in no uncertain terms that we don't like to talk about Windows here. So I'm going to break out of the presentation, and besides, I think you folks might like this. We're going to do a live demo instead, because I'm a confident person. All right.
You have to talk to Murphy very often.
So, I told you about how great all this Sanoid stuff is, right? Well, I'm actually running the Sanoid platform on the battle station here. And let me go ahead and make this text a little bigger so we have a shot at seeing it. Profile preferences. Yeah, there we go. Font. Okay. All right, that look pretty readable for everybody? Cool. Okay, so we can see, here's our Sanoid conf, and it looks a lot like that slide that we showed before. Z is the pool on this laptop, and images is where I store those VMs. And you can see that we've got use template production, which was defined just like it was in the other slide. We got a couple of new wrinkles though. We said recursive yes and process children only, because this laptop is running a newer version of Sanoid than what I originally documented in this presentation. And the recursive means that for any data sets that exist under images, they're going to be covered automatically by that policy that we defined. Process children only is because Z images itself is just a placeholder. Its only function in life is to hold data sets for individual VMs to all have that policy applied to them. So we break out of this. And speaking of antiquated procedures, I like to run as root because, again, I'm very self-confident. All right, so we do a list. We can see under
password to Bob, and then
yeah. So we can see under images, we've got an Ubuntu Trusty Gold. We've got an Ubuntu Trusty Working, a Windows 2012 R2 Gold and Demo, a few other things, and all these are automatically getting snapshotted by that policy, which we can see if we do a list RT snap. We're going to look at all the snapshots of Z images Ubuntu Trusty Working. And you can see it's been automatically taking snapshots. Cool, that's important because I'm about to do something really stupid. All right, so we'll go back to Virt-manager and drag it over where you can see it. Here's Virt-manager. You can see we've got our Ubuntu Trusty VM running. Cool. So we're looking at our Trusty VM. And before I do anything else, you remember I mentioned that performance was really slick under Sanoid? I'm going to demonstrate that. I usually like to reboot Windows because everybody hates that. Rebooting Linux is a little less impressive because you don't have to do it that often, so you don't have that same level of just ingrained hate. But at the same time, you just saw a reboot.
Question?
Yeah.
You just said, you know, we're about to do something stupid.
Yes.
Just say you are about to do something stupid and you know you're about to do something stupid. Can you force a snapshot?
Absolutely.
Okay.
Absolutely. So you're going to be slightly less stupid than I was, but we'll go with your slightly decreased level of stupidity, and we'll say ZFS snapshot Z images Ubuntu trusty working at pre-stupidity.
Yeah.
And boom, we took a snapshot. All right. So now back to our scheduled dumb behavior. We'll go back to our Ubuntu trusty VM, and we're logged into it here, and we will bring up a terminal. Yeah. Okay. Cool.
That's gold, not working.
I just never changed the machine name after I replicated over.
Checking.
Yeah, no worries. This demonstration is about stupidity. So now we're going to do something incredibly stupid. Let's see here. No preserve root. That's an argument that I don't use all that often. So I knew it was going to complain and wanted an extra argument, but I couldn't remember what it was because seriously, this has to be one of the very few times that anybody actually uses this argument, like in any given year, I think. Bam! Here we go. Obviously, it's going to fail at removing stuff under the device files file tree, but it's doing its best. Oh, here we go. Turns out you can't remove the CPU.
Actually seen this done before.
I haven't either. This is educational.
Yay! All right. So, in case you didn't believe me, have we achieved stupidity?
That's great.
Now, due to the nature of modern file systems, so much of it is cached that the file system doesn't just immediately and completely crash. We'd have to poke it a lot to make it actually very visibly die completely. So we'll go ahead and restart it. Even the reboot is going to take a while now because it honestly doesn't know how to reboot. So rather than wait for it to figure that out, we'll go ahead and force it off. Yeah, and we'll try to fire it up again. And of course, we're into grub rescue. So obviously this thing is well and completely hosed, right? So let's go ahead and force that off again. What make do? And all we need to do is come back here, and instead of ZFS snapshot, we'll say ZFS rollback. And we'll come back here to our VM. And oh, I got to drag it back over there again. Yay!
Hey, where's your...
Restore from backup doesn't get a whole lot easier than that.
Where's your GUI? Black MR.
Oh, that's good. Oh, wait a minute. What did we do?
We restore.
Man, all right. So
We'll give you a whoops. I mean, that's
that's all right.
Especially during a live demo.
it's still impressive.
That's all right.
We'll give you a whoops.
We're not done yet.
Roll back now.
Yep. Let's go back to our last hourly here. CFS rollback. Law. Whoop. Law. Go back.
It's minus off.
Of course, I probably should have done that. Okay, good. The VM was turned off.
Question.
Yeah.
I noticed this time you used a -r parameter, the previous time you didn't.
I wasn't entirely sure that it hadn't taken another snapshot. If there's a newer snapshot since, then it will refuse to roll back unless you give it a -r for recursive to say, yes, really, I want you to go back more than one snapshot. So, boom, there you go. We're back. And Is there an easier way to restore from backup? Not that I've found. And keep in mind that even if I could have replicated this thing over a LAN or over a VPN link to another box completely and picked this thing up and chucked it into the volcano at Mordor and just fired it up directly on that other machine. Even then, it wouldn't necessarily be a restore procedure so much as just booted. That's it. That's all you got to do. Before we move on completely,
Jim, do you replicate your laptop to another laptop or another server?
I don't, because there's nothing on it that I value that much. If there was, then I would, but there isn't, so I don't. It's the other way around. That Ubuntu Trusty, the gold got replicated in from my server today, and then got replicated over from the gold to the working image. And as you saw, I didn't bother renaming the host or the file name underneath it or anything. I just did Sanoid over, and that was it. If you want to see what that looks like, that's also kind of cool. So, ZFS list, let's do a ZFS list. So we got the Ubuntu Trusty working and Ubuntu Trusty gold. Like I told you, the way that the working actually came about is I just replicated over from gold, right? Well, I could actually do the same thing again. I can say, now this is destructive. And for that reason, actually before I even do that, let's just do a whole. All right, so Sanoid, Z images, Ubuntu Trusty working.
Could go to working 2.
Images, yeah, exactly. Ubuntu 2, because I'm tired of typing. And this is going to go pretty rapidly because this laptop has a really nice solid state drive in it. And we've only got like a gig or so worth of data because it's a pretty clean Ubuntu installation. All right, so boom, 289 megs a second. We replicated that over. But honestly, the impressive part about that isn't ZFS; it's the solid state drive. It would have been about the same doing a CP. But if we say Sanoid, Z images, Ubuntu Trusty gold, Z images, Ubuntu Trusty working. All right. So what it did is it first rolled us back to the last gold condition and then moved gold over. And I probably should have done that with the VM actually off. I don't know if it will actually boot, given that I had live file systems mounted when I did that. We'll find out. So, and we're not going to have a, we definitely do not have a GUI here because I don't have a GUI installed on the gold image. I only installed that on the working. So, but you saw how quick that was. I mean, that was a matter of just a couple seconds and bam, done. Obviously, that's on the local host, but you can also do that over the network. And yes, that really does scale the way that the implication is. That wouldn't have taken much longer over a LAN link because there just wasn't that much data to change. And while we're here, before we get completely done with all this stuff, so we're done with our trusty VM, and just in case I want to do this again, go ahead and do that the other way around and get Ubuntu 2, I think. Yeah. And boop, 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 boop. And now we're back to where we were on that. All right. So I know we don't care about Windows here, but just because I think this is really cool, we are going to go ahead. So we have, we have a Windows Server 2012 here. We will go ahead and log into that. Yeah. Actually, I think Windows is there. We just can't see anything because I have a black background and we're not entirely. Oh no, there we go. Oh yeah. So this is slow because this was also just cloned off of a gold, and this is literally the first boot into Windows, which is why it's discovering the network and setting up a brand new user account and all that kind of crap. It's literally the first boot into that Windows post installation. But anyway, so we've got Server 2012 here, and I enjoyed demoing a reboot on this. If you've ever had to work with Windows, you have to see a lot of Windows reboots, but they don't usually look quite like that.
Wow.
Yeah. So, like I said, one of the first things that I find that particularly people who've already invested in an enterprise virtualization stack and are well aware that they've spent anywhere from $250,000 to $3 or $4 million on their infrastructure, it's like, well, okay, great. So you squished it all down into that one little box or whatever, but performance can't be that great, right? Oh yeah. All right, and so let's get back to our presentation. Rock it back through our slides. Okay, so we kind of already looked at that, but the replication, this is very key. This is how we make sure that the building burning down doesn't completely destroy our business. It's how we make sure that the motherboard catching on fire in your production host doesn't put you out of business for a day or so worth of interrupted business continuity. And what we've got right here is a demo. You remember I mentioned that customer that had the 2.5 terabytes worth of VMs, and their offsite DR is literally a box sitting in the upstairs living room /den/kid playroom of one of the owners, tucked in behind the TV where the kids won't pull the wires out of the back. And first thing I'm doing here is I'm doing an iPerf to test the network connection from the offsite to the onsite. And you can see we've got a whopping 1.15 megabits available. The next thing I do is I list the file server image on ZFS, and we can see 2.54 terabytes allotted. Some of that is snapshots, but you can see a full 2.14 terabytes is the live file system, just the VMs in there. So the next thing we do is a Sanoid from the on-site box images file server to the local file server, and it's going to update that 2.14 terabyte data set, which it does in 13 minutes and 36 seconds over that crappy little DSL connection. Again, do not try this with rsync, ladies and gentlemen. The other kind of cool thing, you may notice that we're seeing 1.11 megabytes per second over this connection. And if you're more technically minded, you might say, hey, wait a minute, those two numbers are similar, but that's megabits, that's megabytes. What gives? What gives is that Sanoid is not only ZFS replication. I should mention Sanoid, notice the name Sanoid. Sanoid is a tool that I wrote to automate ZFS replication. You can do ZFS replication by hand if you've got 15 to 20 minutes to kill to figure out what commands you need to run. It's different every time. You got to figure out what snapshots are here and what snapshots are there and how you're going to get them from A to B and exactly what you want the arguments to be. Sanoid's very, very simple. Just Sanoid, source, target, that's it. It takes care of all of it, whether it's local or remote, on which end, push, pull, doesn't matter. One other thing that it does is it adds in network buffering, and it also adds in dynamic LZO compression. Most working data sets are very, very compressible. A lot of the data that you actually have to move on any given day out of these working VMs is really just kind of temporary file system thrash and trash. That kind of temporary crap is very, very compressible, which is why we're seeing 1.11 megabytes per second over a 1.15 megabit connection, because we literally were getting that much compression out of that. You have to move that useless file system thrash, but that doesn't mean you have to move it uncompressed. So in the event, and yes?
So that 1.1 megabyte, that is not transfer ratio, that is processing ratio.
I don't know whether to say yes or no to that, so I'm just going to say that that's...
Is that 1.1 megabyte, 1.1 megabyte going over my cable or being processed by your program?
Right, that's 1.15 megabytes before compression. The compression happens before the cable, so what you're actually seeing over the cable is going to be that, roughly 1 megabit. But what we're actually seeing in terms of our data, we're moving our data that we care about in total at 1.1 megabytes per second. All right, so anybody here know of anything newsworthy that's happened in Colombia recently?
Massive floods.
Yeah, we had really, really bad floods down there. I came out of it fine, but it was still kind of a sobering moment for me because the apartment that I lived in before I bought my first house was literally 4 feet deep in water on the inside. And I'm looking at pictures of this on the news, and like cars are literally bobbing in the parking lot, and the parking lot was like full, like nobody left ahead of time. And I'm looking at that thinking, that would have been me. Remember, our theme tonight has been stupid things that I'm doing in front of a live audience. I can guarantee if I'd still lived in that apartment complex, my car would have been bobbing in that parking lot with everybody else's, and I literally would have been swimming to the road from my apartment. So that was sobering to look at, but more relevantly, these folks right here that we're looking at this demo of Sanoid running for, they are right next to a lovely feature named Gills Creek. And about a quarter of a mile from where their business is, there were a couple of buildings that you may have seen shots of on the news that were completely destroyed, walls buckled, roofs caved in, all that. For close to a week, we didn't know whether these folks were going to be in the same situation as that title loan place, heck with them, that you know, got destroyed in the flood. So we're sitting there wondering, like, is everything going to be okay or not? You know, I've got active monitoring, but all that's really telling me is the network's down. No kidding, the network's down. You know, but is the building in place? I didn't have any metrics for that. But the awesome thing is, you know, I actually got calls from the business owners, from several of the business owners, while this flooding was going on, and literally nobody could even get to the office to find out if it was dry or if it was 3 feet deep in water, saying, oh my God, I'm so glad we listened to you and did that offsite backup, and we know for a fact that our data is safe. If the whole building is destroyed, that sucks, but the building's insured. Data's never insured. If somebody tells you that your data's insured, it's a lie. There's no such thing as data insurance. But we knew that, you know, worst case come to worst, when we come in and we discover that, you know, we now have an office building that has lake in front of the name. You know, we can grab that box out from behind Trey's TV, set it up in a construction trailer somewhere, turn it on, connect machines to it, and do business like nothing ever happened. That's huge. All right, so, you know, we started talking a little bit about topology. You know, those folks, coastal science and engineering that I was talking about, it turned out not to be a lake, by the way. The water came up to the doorstep on the outside, but not above the doorstep. So inside the building was fine. Yay! What we've talked about for them is basically what we're looking at here. We've got a production host, we've got an offsite disaster recovery host, and we're doing daily offsite replication over an open VPN tunnel, which works really well. But we're still missing a key feature here, because all we've got is the production of the offsite DR. If the motherboard dies in production, well, now we have to worry about, okay, do we repair that, or do we go out to Trey's house in Blythewood and grab the server and drag it back and do the blah, 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 blah. You've got a lot of interruption either way. So we can improve on that. We add an on-site hot spare. So now we've got 2 boxes. We got any networking folks in the room? Yay, he'll admit to it. So we've got 2 boxes, and they're in the same building, but more importantly, they're on the same broadcast domain for the network. So what that means is, if we take the production host over here and we take a sledgehammer to it and just bash it, bash it, bash it, bash it until it's dead, the hot spare host is still on the same broadcast domain, which means that when we spin up the VMs on the hot spare host, there's no reconfiguration needed. Your most recent hourly snapshots are up and running. All your users are connected to it like nothing ever happened. You don't have to go to any user's machine and tell, oh, well, let's remap your H drive to an I drive from that. No, it just works. As far as your users are concerned, you've hopped back in time to the most recent, you know, top of the hour, but other than that, you're up and running. There's nothing left to do. So even if you're not on site, remember I mentioned that Virt-manager works over SSH tunnels. You can manage this stuff from anywhere. You can get consoles, you can start VMs, you can stop them. If I got a call from a customer right now that's like, oh my God, the production machine caught on fire and we're having a big sale right now, we have got to be up right now, I would ask you folks to excuse me for a minute, and I would connect over the VPN from my laptop, and I would spin up their machines on the hot spare, and I would hang up the phone and we'd be done, and I'd go on with the presentation. So this is really, really amazing, career-changing stuff for sysadmin. Yes?
So the caption there said, or HA if you're froggy. So I know HA is high availability. I don't know
Yes.
what froggy is, and I don't think I want to know. But like, how exactly does the high availability work there?
Okay, so this is not, what we're looking at here, this is not HA, high availability. High availability is a very specific term that basically means if you bash this machine with a sledgehammer until all the magic smoke comes out, automatically if you've got HA, everything just gets, it starts running off of the hot spare, and there's no interruption in continuity, and there's no loss of data. Everything just magically works. True HA is very frequently a complete evil lie. True HA also has a lot of potential pitfalls with it. I don't like HA, if I haven't made that clear yet. It's complex, it usually doesn't perform very well, and the nasty thing about something that will automatically fail over is it might think it's smarter than you are. So ask yourself the question, so we have this set up, and this machine is just sitting here waiting, and it's ready to take over if it needs to, but this machine's just keeping on trucking, so this is the machine that you're doing all your work on, right? Well, what happens if this machine is still running, but the link between only these two machines dies, and now this one says, hey, I'm the boss now. I'll promote myself to master. Everyone, do business with me. Now your users see both of these machines. Both of these machines claim they're the master that they should interact with. What will typically happen is some fraction of your users will now start saving data onto this one, and some of them will now start saving data onto that one, and a couple of hours later you'll get a call because something looks a little funny. You'll puzzle and scratch your head and eventually go, oh crap, I got a split brain going on. Both these machines think they're the master, and you now have several hours worth of work that is just completely screwed up because some of it's on that box, some of it's on that box, some of it's completely hosed because half of the individual thing went to two different places. And inevitably you have some users saying, my stuff is on this one needs to be the master after we're done with this. And some other users say, no, my stuff is on this one needs to be the master. And then some C-level who barely knows how to find the power switch says, well, you need to mush it all together and have all the good stuff on one. No. Setting expectations is really, really key. If you work in an enterprise that has HA and thinks HA is a good idea and wants to continue to have HA, the point behind this is HA is independent of this kind of replication that Sanoid does. Sanoid doesn't do HA. It doesn't stop you from doing it. If you wanted true HA, you wouldn't actually do the Sanoid replication between these two boxes. You would set up the two boxes and you would set up HA and DRBD, which is Linux high availability, heartbeat, distributed block device, and do HA the same way that you've always done HA. Once that completely fails and dies in a pool of fire, then you'll go back to this box over here that didn't have that problem and still works. Okay, we have any Latin fans in the house. Who watches the Watchers? And the answer to that is Nagios and OpenVPN. What we're looking at here is, if this was a conference, I would have a little miniature rack with a couple of boxes in here. And this is actually a screenshot from the demo hardware. And we're looking at Nagios, and it's monitoring hosts and guests on the network. The cool thing about it is that it's not doing it just naked over the network. It's actually doing it over VPN tunnels, hence the OpenVPN logo there. The other cool thing is the way I do my monitoring networks, not only do you get a dynamic private VPN IP address, you get a dynamic host name that actually resolves to that IP address. So if you're connected to the monitoring network from a trusted machine, you don't have to remember that 10.8.0.30, oh, who cares, is the backup server. You can just look at demo.backup.vpn and that will resolve. It won't do any good to anybody outside the monitoring network. It won't do any good for anybody that's attached to the monitoring network from an untrusted, a monitored position. But if you're the boss, you don't have to remember a bunch of crazy IP addresses. You don't have to set up crazy, complex, nasty host files. You can just do DHCP like you always do and have these nice little private TLDs that actually work. This is a lifesaver. I use this in practice in my consulting business. My clients are connected to my own monitoring network, and there are a couple hundred machines that I can SSH into or I can RDP into just directly with a nice human-readable company name, .machine name, .vpn. Looking at the actual checks that Nagios is doing here, we're checking to see that our SSH service is up. And I should keep in mind, I should mention, for any of you who aren't familiar with monitoring and Nagios in particular, when I say here that SSH is up, we don't check that by doing like a process list on the box and going, oh, that's an SSH daemon. We check that by actually trying to SSH into the box and making sure that it answers. And if it does answer, then Nagios goes, green light, it's okay. If Nagios can't get an answer from that SSH daemon, then you get a crit. Doesn't matter if SSH is up. If you blocked it with the firewall, you're going to throw a crit here, and your phone's going to start buzzing in your pocket, and you're going to go figure it out. We're also checking for disk space on mounted volumes. So if we run out of room anywhere on that machine, again, we'll throw a warn or a crit. We're checking for the health of the root disk, obviously very important. Now this is a host that we're monitoring here, this demo.backup.vpn. This is the hot spare in my little demo rack, right? So it has all these snapshots like what we looked at earlier. And this plugin right here checks for snapshot freshness. What that means is, in that same Sanoid config file where we saw we had our production template, one of the things that's defined by default is how new a snapshot should be under a given data set. And so that means if we don't have an hourly that is less than 61 minutes old, we're going to throw a warn here. You're going to see a yellow warn. And if that snapshot gets to be, if the newest hourly snapshot gets to be more than 2 hours old, then you're going to throw a crit, and your phone's going to start buzzing in your pocket, and rather than finding out 6 months later that your offsite replication wasn't working when you desperately need it, you're going to find out a couple of hours later, and you're going to go fix it before it's an issue, which is huge. Check storage pool health. So obviously, departing from our theme tonight of doing incredibly stupid things, we are setting up redundant storage pools with ZFS. Maybe you're setting up a RAID Z array, which is kind of like RAID 5 or RAID 6 and has, a stripe of parity. Better idea, maybe you're doing a pool of mirrors where you're using redundancy instead of parity. But either way, you can afford to lose a disk. When you do lose a disk, this plugin is going to tell you about it, and you're going to throw a crit, and you're going to go fix it before you lose another disk that you can't afford to lose. And finally, we're monitoring system load, which obviously is configurable. That one actually uses an algorithm that checks to see how many cores you have, which determines how high your load should be acceptable before you should be going, why is my Unix server, like 150 load metric and not actually accomplishing anything? And again, you want to. This is how you want to find out about these things. I'm not any different than anybody else. There was a time when I found out about these things. Sometimes 2 or 3 hours after they happened, sometimes 2 or 3 days after they happened, when the users called me. And the one thing that is unifying across all those scenarios is no matter how long the users labored along without anything working and didn't tell you in any way, shape, or form, by the time they do call you, they are counting back to the very moment they thought there might have been a problem, not to the moment they called you. So this is the difference between, at worst, a mildly annoyed user because things just broke and they may or may not have even noticed it yet, and a flamingly pissed off user that wants to know why it's been down for the 4 days that they haven't called you. And that pretty much concludes our canned presentation. Has anybody got anything else you want to talk about? Questions?
I have a couple. I guess first question is, most of what you're talking about is hourly replication. Is there is there a reason you don't crank it down to quarter hourly or 5 minutely or something like that?
The major reason that I'm not doing it every hour or every 5 minutes is because all of my users think this is incredibly awesome black magic and it's the best thing they've ever seen, and I have no desire to push it to where something might break before somebody demands it. If you run your own business, one very critical principle is once somebody buys, you stop selling. And so the thing about this is, when you can tell a user, so let's say I have one particular client who has gotten CryptoWall twice in this last year. Is anybody here not familiar with CryptoWall? Awesome. So CryptoWall is this god-awful malware that emerges from the depths of Eastern Europe. And the way it works is if a user clicks the shiny link on the email and decides to find out what, in fact, the IRS sent them in a zip file, they get CryptoWall. CryptoWall runs on their machine. CryptoWall immediately looks at all of the local disks on the machine and every single shared drive on the network that it can find, and every file that it can find and every location that it can find, it immediately begins encrypting. So it's encrypting it with one key out of a pair. And the other key in that pair is never on your machine at all, or even in the same country, unless you happen to live in Romania or wherever the heck this guy's from. And so after it's encrypted a certain number of the files, you start seeing little ransom files popping up on your desktop and in various directories. Help readme.html, and you click it, and you get a helpful message about how all of your files have been encrypted and you don't have the key, and this person does. And here's how you use Bitcoin to buy blah blah whatever. And long story short, give this guy like $500. After which you hope that he, or well, let's be fair, or she, will give you the key. Now the interesting thing is, so far, they're quite willing to give you the key once you pay the ransom. Most people who have elected to pay them have had the happy-ish result of getting the key and the tool they need to decrypt all their files within a week or two of buying Bitcoin or Western Unioning money to some Dropbox in Bulgaria or Romania or wherever. I did mention business continuity, right? Down for 2 weeks. The other thing beyond that is, I don't know about you, but I don't want to give that person money. It's the last thing I want to do. If I can figure out a way to Western Union them an ass kicking, I might be interested. Money? No, not happening. But the unfortunate reality, I'd like to say the unfortunate reality in the small business world, but let's be honest, the unfortunate reality in all slices, mid-market certainly, and even enterprise, is that you may not have good backups. You may try to go to those backups and spend a day and a half and find out that, this giant monolithic blob that my enterprise backup utility created on this tape is actually no good to me whatsoever and won't work. Or you may say, oh, our most recent backup was 3 weeks ago, I can't afford to lose that much data. A lot of people end up paying the ransom and hopefully getting their key back, which they usually do. If they don't, they're just boned. And the other thing about that is, again, you're talking about a lot of lost business continuity. Best case scenario, your nightly backup last night at midnight was perfectly good. Sweet. All right, well, you lost all your data today. So you're rolling back to whatever condition you were last night at midnight. Also, if you're doing conventional backups, somebody feel free to tell me a liar if you think I'm wrong, but you're also going to lose another, probably at least a man day. Maybe you can cut it shorter than that in terms of real time if you've got an IT department with multiple people. But you've got to restore off these tapes or the external hardware or whatever. You've got to do, like if it's Windows, you got to do a clean server install and then start trying to restore your backups from the tape onto that and hope the whole thing works at the end. I mean, you're down for days just to do just to restore from the backup. With this, roll back.
And of course, you practice that backup restore process every couple of months, right?
You might as well, because it takes 5 seconds. Why wouldn't you?
No,
That's the other thing.
I mean, if you're backing up off tape.
So doing a test restore off of conventional backups is a painful procedure. I've never actually seen it done in small business ever in 20 years of being a professional full-time consultant. In theory, what you're supposed to do, this goes back to my friend Tim from the first slide, the policies and procedures that we follow, you should have this alternate test lab network with identical hardware to everything that you've got in production, and about once a month or once a quarter, depending, you're going to burn a solid 1.5 person days doing a test restore off of your tapes onto this hardware to make sure everything works and poke around in it and blah, blah, blah. I'm not kidding about the day and a half that takes, and you need to have the alternate hardware and the alternate network and the alternate everything. Nobody does that in small business all too frequently. I'm happy for Tim that his department apparently did all that for his insurance firm. It doesn't happen a lot in mid-market either. Whereas, as the gentleman here pointed out, if you're using Sanoid, why wouldn't you test it? Fire it up directly on the backup server. Open up Virt-manager, your connection to the backup server. You don't have to get up from your desk, boot up the backup stuff, log into it, see if it works. You've got a whole complex network of VMs. You've got a database server, an app server, and a file server, and a domain controller over here. Fire it all up on the backup box in an isolated virtual network. Log in, do all your things, run all your apps, be done with it in 10 minutes.
So you laughingly refer to having to spend a day and a half to do a restore if you actually have a backup.
Mm-hmm.
If all of my data is offsite and I have a bad employee who burns my building down, but I have one machine on which I can restore stuff, I still need to spend a day and a half to download my data from my offsite. That is still not a problem that is solved.
Nope. Remember I mentioned Virt-manager SSH tunnel to remote machines. Your offsite box that has your offsite images, define VM hardware on those images just like the ones in production, and you don't even have to drive out to your offsite location. Fire it up right there in a console in Virt-manager sitting at your laptop.
So what you're saying is in order to do the backup, I actually have to have all the infrastructure to run my entire offsite thing as well.
You do, except we're not talking about a whole lot of infrastructure. You just saw me firing up. You just saw those 2 VMs running on my laptop. Did they appear slow? That laptop is...
Anything with those things. Yeah.
That's true. I didn't do anything other than reboot them. But that laptop is a pathetic wind-up toy compared to real infrastructure. But the real infrastructure that I actually sell and support and run this stuff off of, you're still talking about an individual box capable of running, anywhere from 5 to 10 VMs doing real work at very, very good performance levels that you spend $5 or $6 grand on.
And how long is my stuff going to run on your machines until I get those backups in my local environment and can restore them?
I'm not sure I understand the question.
So if I understand what you're saying is, if my building is burned down, I can run all of my machines, all of my VMs in your environment because they can run 10 VMs at a time, right? So I don't have to spend that time pulling all the data down into my local new on-site area.
Yeah, so if the building burns in, if you've got the full 3-way topology, you've got a production, you've got an on-site hot spare, and you've got an off-site DR, the building burns down, the next thing that happens is you arrange for a construction trailer to be pulled up on the lot while you're dealing with your building issues. probably the first thing you're going to do is you're going to go to your offsite location, you're going to grab that box and drag it and plop it in the trailer and fire up all your stuff immediately right there on the hardware and run right then. You're also going to, as rapidly as possible, get a new box to serve as a backup, replicate, which you can do while it's all running, replicate onto that in your trailer and get that the heck back offsite again.
Okay, that's what I need to hear. How much is that going to cost me?
I mean, it's going to depend on what your actual workload is. I very frequently, so talking about my specific hardware that I sell, there's basically 3 levels of it. There's a Sanoid Small Business, Standard, and Pro. The Small Business is usually going to be good for 5 or 6 VMs doing a pretty serious amount of work. If you want to load that, and that's going to be a Xeon E3 with 32 gigs RAM in it. If you were to load that with a couple of terabytes of redundant, fully solid-state storage in there, which will blow your freaking mind performance levels, you're looking at about, with the storage, somewhere around like $3,000 a box.
Okay. Last question. Sorry, last question. What you're doing with
Yeah.
CFS is basically differential backups, right? That's really what's happening.
Ish.
Also, I hope they're differential backups.
I hate when people make that comparison,
Okay.
because it's true in one way. You're familiar with the spirit versus the letter of the law? What you're saying is correct by the letter of the law. By the spirit, it is a horrible, awful lie, and you should stop saying that.
Okay.
So a differential backup on tape, and here's the crucial difference. Either way, you're talking about only moving the changed data over, but with differential backups on tape, if you want to restore that, you have to start out with the last full, and then you have to apply every single one of the differentials since then as a patch, one after another in sequence. You lose any individual one, and you're completely boned. That's not the way that asynchronous incremental replication works. The way asynchronous incremental replication works is you have a full file system containing, let's say, 30 snapshots on this end. You also have a full file system already assembled, ready to go with 30 snapshots on that end. Make a new snapshot over here, move the snapshot over there. But you don't have to patch or apply or do weird stuff to restore. It's identical on both ends, all of it ready immediately. That's the difference.
Can you speak a little bit to setting up and configuring Sanoid? It looks like it could be a bit fiddly.
It's not too bad, honestly. I mean, so it's not just like apt-get install Sanoid and you're done. But it's really not that bad.
Coming in the next version.
So the way that I would set it up is, the first step is Ubuntu is my underlying host OS of choice, so I would install Ubuntu server on the box. The next thing, we're going to need a few dependencies, which are going to be libconfig, inf files, Perl, and then really that's the only hard dependency other than ZFS itself. You'll need to install ZFS on Linux. And then ideally you'd like to have a copy of LZOP and mbuffer and PV available. PV will get you the nice little progress bar that you saw while we were synchronizing. LZOP does the inline LZO compression, and mbuffer does the network buffering. If you have all those things, then you get all the special goodies. Once you've done that, Sanoid itself, technically Sanoid is just snapshot management. The virtualization is KVM, managing the VMs is Virt-manager. The storage is ZFS. What Sanoid itself in a code sense does is, when you want to just be able to say, okay, my VM is under data images, so I know for a fact I'm getting snapshot every hour. I know for a fact that after 36 hours of continuous snapshots, the one that's 37 hours old will get deleted. I also know for a fact that if I only have 3 snapshots, but one of them is 37 hours old, I ain't going to delete that 37 hour old one because I only have 3, and until I have 36, I'm not going to delete the oldest one. All kinds of little logic traps are taken care of for you. You know that if you want to change your policy and you want more hourlies or less hourlies or more dailies or no dailies or some monthlies or yearlies or whatever, you can just define all that human readable. You can apply it recursively. You set a policy in a template and apply it and be done. Before I wrote Sanoid, I was doing all these same things by hand with ZFS and KVM, and it worked. But I started finding myself scaling further and further because KVM was so awesome and ZFS was so awesome. I wanted to do more and more on a box. I wanted to segregate functions out to individual VMs more and more. And I discovered that when you're doing all this stuff by hand, you can do it all by hand. You can just have a whole bunch of cron jobs in Root's tab. But if you got 10 VMs on a box, you have pages of cron. and you can screw it up individually in a new and unique and fun way on any given one VM when all the rest of them are fine. Or you can forget to set it up, the automated replication, or the automated snapshotting, or the thinning, or the whatever for any one individual VM, and not find out about it until you need it. So after I got to the point where I was like, oh, this is terrible. Actually, I have to give part of the credit to Todd. Todd kept yelling at me that I needed to automate this until I automated it, because for a long time my position was, I know what I'm doing. And you know, again, even doing it manually, I mean, it was still so awesome compared to not having ZFS and KVM. I was like, why do I need to do that? But after I had an incident bite me, not fatally, but bite me enough to really get my attention on a box that did have 10 or 12 VMs on it, and I literally had pages and pages and pages of cron tab, I was like, okay. And I took a long weekend, and the wife and kids and I went to my mom's house in Mississippi, and the deal was you keep every human being away from me until I've got, you know, version 1.0 done. And that was what I did. And it's just kind of grown since then. Syncoid, the same thing. You know, although honestly I didn't use ZFS replication much at all before I wrote Syncoid, because it's just as awesome doing it by hand, but oh my god, it's a pain. Because what ZFS is really doing is saying, okay, you have this snapshot number 1 on the source box. Okay, cool. Now you have to go and say, all right, well, do I already have snapshot number 1 on the target box? Because if you do, well then, okay, now you see, is there a snapshot number 2 on the source box? Okay, cool. Is there a snapshot number 2 on the target box? Yes? No? No? Well, then we need to do an incremental from 1 to 2 from that box to this box. If we did have 2, okay, well, is there 3? Is there 4? Is it? And you've got to find all this stuff and put it together. Or does the file system not exist at all in the target box? Well, now instead of an incremental send, you've got to do a non-incremental send, which is a different syntax. We have to find all that out first and then do the thing. And we haven't even talked about piping through SSH, or compression, or buffering, or bandwidth shaping, which Syncoid can also do, recursion, none of that. This is just, I want to get a file system from A to B. And I mean, literally, even when you know what you're doing, you spend like 10 minutes listing snapshots and comparing notes, literally jotting things down on a piece of paper to make sure you get it right. Whereas Syncoid, as you saw, just one command and done. It figures out, does all the donkey work for you. So that was a big deal. Once I had that tool, I used replication everywhere. I very rarely use rsync for anything anymore. I use rsync if I'm not using ZFS, and honestly, that's pretty much it. Or I'll use it as a smart copy tool sometimes.
So a decade or so ago, as a Solaris admin, we used ZFS.
Mm-hmm.
And it was great for a year and a half or 2. And because it's copy on write, you get incredible fragmentation. And once you get above 80% utilization, performance tanks. And we switched from ZFS to
Let me tell you a secret though.
UFS mightily fast, and performance came right back.
Let me tell you a secret though. You got over 80% utilization. Stop doing that. You can't fill a hard drive full. It's not a jar of candy. It's like a little sliding puzzle, man. You got to have the hole. If you don't have the hole, you can't move the pieces around. The whole thing just sits there and sucks. That's not ZFS's fault. You guys are using your storage wrong. I will also say that you were talking about an incredibly early version of ZFS. That was before OpenZFS existed. That was before ZFS was even ported to BSD. You guys were using a beta file system. It has not been a beta system for a long time. My oldest hosts at this point, my oldest continuously operating hosts on ZFS have probably been running for about 5 years, with teams of 20, 30 engineers, hammering on VMs on them. The issues you're describing are not really much of an issue anymore. I will say, again, stop trying to fill it completely full. With that said, I don't fill my systems completely full in terms of the live file system, but dude, I pack them as far as the snapshots go. I very frequently will have machines that are about 90% utilized, including the snapshots. Now the snapshots obviously drop off every hour and every day and every month, so that doesn't really change too much. You do still have some free space, but yeah.